Hey guys, I'd like to thank everyone who watched my last video. It was super fun reading all of your comments. I will say though that making that video did not help me get out of my rabbit hole any faster. Nope, it just got deeper. In my last video, I talked about how my reflectivity observations from the Cygnus satellites started looking really weird over northern Africa in mid-2019. And so I started exploring whether or not this weirdness could be caused by radio frequency interference, or RFI. And I did that by looking at the noise level of my observations and saying that higher noise levels appeared to correspond with higher levels of RFI. Since I made that video, a few different people have commented that the big increase in RFI that I'm seeing in Libya starting in mid-2019 is not seen by the SMAP satellite, which is weird because the SMAP satellite and the Cygnus satellites where I get my observations from are both L-band instruments. So I looked at the SMAP RFI data and compared it to my Cygnus observations, and it's true, the SMAP satellite does not see an increase in RFI. So then I freaked out a little bit because I was like, did I just lie on the internet? Nobody lies on the internet, right? But then I found this paper, which I want to spend a little bit of time talking about because it explains so much about what I'm seeing in my data, and it was just kind of fun to read. This paper looked at data collected by a GNSS receiver on board the International Space Station, and most of the paper relates to observations of RFI that they saw over Syria in 2018. The authors write, strong interference is present in both the L1 and L2 bands. L1 interference is a composite of individual signals with a common carrier centered near GPS L1, but each having a unique GPS L1 CA pseudo-random number spreading code. Such interference can be categorized as matched code GNSS interference, a particularly potent form of jamming. Using some special high-rate data that they collected in 2018, the authors were actually able to pinpoint the location of the RFI transmitter. They write that, while the true location is not known, the geolocation solution based on the model plausibly coincides with a Russian-operated airbase in Syria. And then they showed this image of a building on that airbase, and the red ellipses indicate where they think the transmitter is. Now this is cool because this is my map of the mean noise and Cygnus data in 2018, which was the same time period used in their paper. And here I've started the color bar at 43 dB because that's about when it seems like noise is getting suspiciously high. And if we zoom into the map, we can see that the highest values are centered on Syria, and that white dot is where the maximum value is. Well, guess where the Russian-operated airbase is? It's right there, where the green dot is. What? That's pretty close, considering I don't know what I'm doing. So it seems like the maximum value of my mean noise maps appears to correspond roughly to the location of the RFI transmitter. So I want you guys to remember that for later. Towards the end of their paper, the authors write, an additional hotspot is present to the west of the Syrian location. This hotspot, which emerged in the second half of 2019, is consistent with reports of GNSS interference in the Libyan region. Yes, Libya, second half of 2019, that's what I see too. And then the authors reference this website run by Homeland Security where I guess you can submit your observations of RFI or your trouble using GPS. And in mid-2019, reports started pouring in off the coast of Libya. From July of 2019, one report writes, loss of all SAT positioning reference systems. Problem started when sailing from Malta. Other vessels experienced same problem. Time period without receiving signals seems to be erratic, from 10 minutes to several hours, no pattern. Seems to be jamming. And then in late December of 2019, our vessel is underway from Greece to Tripoli, Libya. When our vessel is at 50 nautical miles from Libyan port, disruption or interference of GPS signal. We stayed at anchor for 2 days already, and yet no improvement of the disruption, and it continues every day. This is not the first time it happened, but every time we were inside of 50 nautical miles from Tripoli. And several other reports on the website also reference the intermittent nature of the RFI, and I've seen that in my data too. On some days, only one or maybe a few GPS satellites seem to be affected, while on other days, they're all affected, and I really haven't been able to find a pattern to it. So the interference is there, and I'm not lying on the internet, at least not yet anyway. Maybe SMAP doesn't see this interference because SMAP and Cygnus, while they're both at L-band, are at slightly different frequencies? I don't know. So this paper did not try to pinpoint the location of the RFI transmitter in Libya. But remember how I said that the maximum value of my mean noise maps appears to correspond roughly to where the transmitter is? You guys see where I'm going with this, right? Well, when I mapped the mean noise over Libya, what I found was that the location of the maximum value actually changes over time. Between June of 2019 and May of 2020, it was centered in between two cities, Tripoli, the capital, and another city to the east, Misrata. And these cities are where the majority of the RFI reports were made. But starting in June of 2020, the source moved. Now the center of the source is close to the town of Sirte. And this timeline is interesting. I found an article written by Al Jazeera which notes the following. Since 2015, a power struggle has pitted the Tripoli-based GNA against renegade military commander Khalifa Haftar, who claims legitimacy from an eastern-based elected parliament. Haftar has been trying unsuccessfully to seize the capital since April of 2019, with support from Egypt, Russia, and the United Arab Emirates. Since the start of June, increased Turkish support has enabled pro-GNA forces to take control of northwest Libya, ending Haftar's assault on Tripoli. The GNA advance is now halted outside the coastal city of Sirte, a strategic access point to Libya's key oil fields, which remains under Haftar's control. So was the transmitter moved in June of 2020 from its original location near Tripoli to the town of Sirte because of the geographical shift in conflict? Or is this just a coincidence? I don't know. The coincidences are intriguing, but they could just be coincidences. And this has been a really fun story, but for now it's just a story. And I haven't talked at all yet about whether or not I could fix or flag my reflectivity observations that are affected by all of this RFI. But I promise I will do that next time.